Today, in this session, we're going to discuss about mole concepts and stoichiometry. Mole concept. Mole, that is, these are the very basic concepts of this chapter and this topic. You should know about the mole of atoms. That is, 1 mole of atoms actually contains. See how if you are talking about 1 dozen of apple, it contains 12 apples. Okay, 1 dozen of pencils, 12. Okay, so same way 1 mole of atoms contain 6.022 into 10 to the power of 23 atoms. Okay, and mass respective to this, okay, atoms is equals to its gram atomic mass. 1 mole of atoms contains 6.022 into 10 to the power of 23 atoms, having the mass equals to its gram atomic mass. Example, 1 mole of oxygen atoms contains 6.022 into 10 to the power of 23 atoms of oxygen and weighs 16 gram. Okay, 1 mole of oxygen. If you are talking about 1 mole of oxygen, that is you have to you are talking about 6.022 into 10 to the power of 23 atoms. You have taken 1 mole of oxygen and you will find 6.022 into 10 to the power of 23 atoms of oxygen. What about the weight respective to this number? That is the weight respective to its gram atomic weight. And what about the gram atomic? What is the atomic weight of oxygen? It is a 16 AMU. When you write it in a gram, that is the gram atomic weight, okay, of that particular element. That is, we are talking about the gram atomic weight of oxygen, so it is a 16 gram. Okay, so 1 mole of oxygen contains 6.022 into 10 to the power of 23 atoms of oxygen and weighs 16 grams. That is gram atomic weight. 1 mole of oxygen atoms contains 1 mole of oxygen atom 1 mole of oxygen atom contains 6.022 into 10 to the power of 23 atoms, weight equal to its gram atomic weight, that is 16 gram. Suppose if you are talking about 1 mole of sodium atom, okay, and you find 6.022 into 10 to the power of 23 atom. What about the weight? Weight respective to its gram atomic weight. 1 mole of nitrogen atom contains 6.022 into 10 to the power of 23 atoms, weight equal to its gram atomic weight, that is 14 gram. So if you are asked to write the gram, that is weight respective to the 1 mole of nitrogen atom, okay, that is, they are talking about its gram atomic weight, that is 14 gram. 1 mole of nitrogen atoms contains 6.022 into 10 to the power of 23 atoms. The weight equals to gram atomic weight, 14 gram. Mole of molecules. 1 mole contains 6.022 into 10 to the power of 23 molecules and its equivalents to the gram molecular mass of any given substance. 1 mole of oxygen molecules contains 6.022 into 10 to the power of 23 molecules. See, if you are talking about 1 mole of any molecule, that is 1 mole of molecules, that is, it contains 6.022 into 10 to the power of 23 molecules. Okay, what about the weight respective to this molecules? These many molecules, that is weight respective to its gram molecular mass. Example, we are talking about 1 mole of oxygen. It contains 6.022 into 10 to the power of 23 molecules. What about the weight respective to this count? That is weight is equals to its gram molecular weight, that is 32 gram. If you are talking about 1 mole of water, it contains 6.022 into 10 to the power of 23 molecules. Weight respective to this molecule is its gram molecular mass, 18 grams. What about the molecular weight of water? It is 18. Okay, when you write it as in gram, okay, that is its gram molecular mass. So 1 mole of water contains 6.022 into 10 to the power of 23 molecules. Weight respective to this molecules is the gram molecular weight of water, that is 18 gram. Okay, mole and molar volume. 1 mole of any gaseous molecules occupy 22.4 decimeter cube, or you can write it as a liter or 22,400 centimeter cube, or else you can mention it in ml, that is 22.4 decimeter cube or 22.4 liter or 22,400 centimeter cube or 22,400 ml. This volume is known as molar volume. Okay, so any examples you can take in, that is you can take, that is 1 mole of oxygen. If you're talking about 1 mole of oxygen, you find 6.022 into 10 to the power of 23 molecules. What about the weight? The weight respective to its gram molecular mass, that is 32 gram. What about the volume it occupies? It occupy molar volume, that is 22.4 liter. The given question is the gram molecular. You are asked to find out the gram molecular mass of nitrogen if 360 centimeter cube at STP weighs 0.45 gram. And the weight is given for a particular volume 360 centimeter, and you are asked to find out the molecular mass of nitrogen. And you should not ask that we all know the gram molecular mass of nitrogen is 28 gram. Why should we have to calculate by step? So this by they are actually giving a practice how to find out the gram molecular mass of a given what about the element. Okay, by this concept. So what is the molar concept? So whatever that is molecules we are taking, we are talking about nitrogen molecules, the 1 mole of it. Okay, the 1 mole of it occupies 22.4 liter or 22.4 decimeter cube or 22,400 ml or 22,400 centimeter cube. Okay, so that weight respective to that volume is a gram molecular mass. But here we have given a weight respective to 360 centimeter cube. So 360 centimeter cube of nitrogen at STP weighs 0.45 gram. So therefore 22,400 centimeter cube of nitrogen will weigh. Why we have to find out the weight respective to this volume? This is a molar volume. The weight respective to this volume is the molecular mass. Okay, so 360 centimeter cube of nitrogen weighs 0.45 gram. Then what about 1 centimeter cube? 0.45 divided by 360. Why should we do this? See, two socks. Two socks. Two socks equal to one pair. If you are asked one sock, or asked to convert one socks into pair, then it is 1 by 2 pair, half a pair, right? If you are asked to find out, you are given 4 socks and you are asked to find out pairs, it is 1 by 2 into 4, 2 pairs. 2 socks equal to 1 pair, 1 socks equal to 1 by half a pair, that is half a pair. But this is how our brain do the calculation. 4 socks, then 1 by 2 into 4 pairs. Okay, like this. 360 centimeter cube of nitrogen weighs 0.45 gram. 1 centimeter cube of nitrogen weighs 0.45 into 360. Then what about 22,400 centimeter cube of nitrogen weighs 0.45 divided by 360 into 22,400. When you simplify this, you get 28 gram. So this problem, okay, in this problem you are asked to find out gram molecular mass of nitrogen, and you are given weight respective to a particular volume, weight respective to particular volume. If we see, we are asked to find out the weight respective to 22.4 liter or 22,400 ml. Why? That is the weight respective to that volume is the gram molecular mass of that particular element. Okay. So 360 centimeter cube of nitrogen at STP weighs 0.45 gram. Then what about the weight respective to this volume? Okay. Why? The weight respective to this volume, that is molar volume, is the gram molecular mass. So 360 centimeter cube of nitrogen weighs 0.45 gram. Then 1 centimeter cube of nitrogen weighs 0.45 divided by 360. 22,400 centimeter cube of nitrogen weighs 0.45 divided by 360 into 22,400. When you simplify this, you get a weight respective to this volume, a weight respective to this molar volume. 22,400 centimeter cube is the molar volume. Okay, so molar volume. So this volume, the weight respective to this volume, is the gram molecular mass of the particular element. Okay.